is less, and therefore it moves faster. So I have established today what is viscosity. Viscosity is property of resistance to flow. But that is not enough. Okay. You will know that different liquids will have different viscosities. We have here in the picture water, honey, ketchup, I mean sauce, then toothpaste. All these different fluids thing will have different viscosities. So tell me, a liquid with high viscosity, will it move slowly or move fast?
Slowly.
Slowly, very good. The same way, liquid with the low viscosity will move faster. Okay, so that is said. But that is not enough for a physicist. For a physicist, we need to go further. We have just learned about the property of viscosity, but now we are supposed to learn how do we measure that property of resistance to flow. In other words, it is called coefficient of viscosity. Coefficient of viscosity is defined as measure of resistance to flow. Now, could you tell me what is coefficient of viscosity? The measure of resistance to flow. Okay, my dear students, let me go a little deeper. This coefficient of viscosity is expressed by the letter eta. Could you see me here? Eta. Eta. It is a Greek letter eta. So how do we calculate this eta or coefficient of viscosity, or in other words, the measurement of resistance to flow of a moving liquid? Just imagine this is a liquid flowing. There are different layers of the liquid flowing. Okay, you pour it on the water on the horizontal surface. Okay, this horizontal surface, there are different layers. Mind you, my dear students, that the layer which is just on top of the surface is at rest. It is not moving at all. You might wonder, if you pour water further, it is moving. But in fact, the layer that touching the surface is not moving at all. But the topmost layer is having the highest velocity. It is moving with highest velocity. The intermediate layer will have intermediate velocity, whereas that which touches on the surface will not be moving, it will be at rest. Let me ask you a question. The topmost layer of the liquid will have a highest velocity, or the medium velocity, or the lowest velocity?
Highest velocity.
Very good, C.S. Raj. So the topmost layer will have the highest velocity, the intermediate layer will have the intermediate velocity, that which is on the surface will have the lowest or zero velocity. Therefore, there is a velocity gradient. See here, I've drawn it. Therefore, there's a gradient, velocity gradient is experienced there. And also you see there is a tangential backward water flow, tangential backward force set up because of the viscosity. So having known this, I'm going to measure this coefficient of viscosity. Therefore, this tangential force, that is F, is directly proportional to surface area. Just imagine I'm taking only this area, okay? Is directly proportional to area. If the area is bigger, the force will be big. If the area is less, the force will be less. And is also directly proportional to the velocity gradient. So I write the velocity gradient in mathematical equation dv by dx. V is velocity, x is the displacement, the place. Therefore, F I can write it as A directly proportional to A dv by dx. If I want to remove this proportionality, I am going to introduce a constant called eta. Yes. So F is equal to minus eta A dv by dx. Why this minus? Because it is backward tangential force. So my dear students, can I measure this eta from this formula?
Yes.
Yes, we can measure.
Yes, sir.
So this eta is, the unit is Newton per meter square second, or in other words, Pascal second. Okay, my dear students, today we saw what is viscosity, what is coefficient of viscosity. I give you a problem. A metal plate area is 2.5 10 to the power of minus 4 meter square is placed onto 0.25 10 to the power minus 3 meter thick layer of castor oil. If the force is 2.5 Newton is needed to move the plate with a velocity 3 into 10 to the power minus 2 meter per second, calculate the coefficient of viscosity. You know A, we know dx, we know F, we know dV. Substitute and you can find, and let me know the answer tomorrow. So another activity, what are the factors affecting the viscosity? Please find out. There are 4 factors affecting the viscosity and there are a number of applications. There's another activity that I'm giving you, and I've also given the YouTube link for you to go through what I've taught you today, as well as I've got this Google form, just given 5 questions, just fill it up after this class. Thank you so much. If you got any doubt, you can ask me.
Thank you, sir.
Thank you, sir.
Thank you, ma'am.
Wonderful class, sir.